think if you look back at the history of the kinds of research that the CB system has done, you'll find that it really is incredibly holistic. And that's really what we need, because the challenges today are, how do we help people understand the relationship between the survival of this lion, which walked near my campsite in Namibia a couple of years ago, and the soil biodiversity. And so that's really what I'm going to begin to at least explore a little bit today, and then talk a little bit about a system that I think may help us further understand those relationships and share the knowledge and information that we need to sustainably manage our lands globally. I'd like to start, though, with a depressing slide just north of here. Go on a bit of a field trip. I know we're all trapped here in Nairobi to Samburu. And what we find here is the legacy of the soil biodiversity lost. And that legacy is actually remembered, not as soil biodiversity, but as a formerly rich and productive system. How many people, when you've been out in the field camping, have noticed differences in how the earth smells as you walk through it? Isn't that amazing, the senses that we use? And that's thanks to soil biodiversity. So Diana said, and has said many times, that soil biodiversity are critical to human well-being, but our ability to disseminate this knowledge remains inadequate. That was in 2013. With this atlas, our ability has significantly increased. I think when you open it, you'll be amazed. It's a phenomenal book. The images that have been produced and represented are just tremendous. This is a soil profile in Alabama in the United States, and I want to take you there because we don't see this soil in Alabama anymore. What we see is this soil profile. We've lost that rich organic layer just as we've lost it in Kenya, in much of Kenya, and in much of Africa. This is a global issue. What happens when we lose that? Well, due to soil erosion and the loss of the soil organic matter and biodiversity, infiltration rates decline, both because of a change in soil texture. We've gone from a coarse sandy texture here to a clay texture here, and because of the loss of those organisms that are maintaining the soil structure and allowing the water to infiltrate. So when we talk about drought, we talk about climate change and the effects that it is going to have, and is perhaps already starting to have. We also need to remember the dramatic impacts that have already occurred through land degradation. Diana showed that slide with a little land degradation citation relative to all of these other things that are going on. And yet, if you look at the impacts of what has already occurred, land degradation far outweighs, and has for centuries, climate change. Now in the future that could change, but right now this is what we're facing. So the relationship between specific organisms and sustainable production, it can be complicated. We clearly need a lot more research to understand this, but overall the impact of soil biodiversity as a part of sustainable management is very clear. This is a nice example of what happens when you leave residue and don't till the soil and allow the soil organisms to do their work. So how do we save our soil and its biodiversity? Part of the answer, we believe, is to connect people through technology to match land use with its potential, make sure we're not exceeding that potential, and apply the best available management. An example of this from the United States, soil erosion on cropland was reduced by nearly 50% while corn yields continue to increase. How was this achieved? Clearly part of it was improved technology, fertilizer, seeds, etc., but a lot of it was simply keeping agriculture on the lands where it's sustainable through a number of US policies that were generated partly in response to our own incredible land degradation that we suffered. And we suffered this because of a resettlement scheme. We talk about resettlement schemes a lot. This was our resettlement scheme in the early part of the 20th century. There were too many people on the east coast of the United States. We pushed them out into these lands that we believed, incorrectly, could be used to sustainably support agriculture. The drought came. It wasn't climate change. It was a drought. a drought like we're still experiencing here today, and the result was this: in mass migration, social disruptions, chaos, violence, etc. Similar situation here in the Bolivian Altiplano. Quinoa production has moved out onto these plains that are not, where it's not sustainable, because we need to see beyond what we see, because that will help us decide what to do next, and hopefully what we decide to do next will in fact be sustainable. What kinds of information do we need? Well, clearly we need soils information. We need to know what the soils are there. Unfortunately, soil maps will never be able to distinguish between very small-scale variability in soil, but that have dramatic consequences. So this is actually based on local knowledge. Northeast Namibia, again, land that will be cropped, and in the first year no manure is needed. Even dry years it can make it. Versus these soils right next to them that are not good for cropping unless manure is applied. What's the difference? Clearly it's not climate, it's not weather. Simply the soil profile. This is a loamy soil. It's a good sponge. It holds lots of water. So if you have a period of 3 weeks without rain, the corn will not die, the sorghum will not die. And this is a deep sandy soil, which can support trees because they put their roots down very deep, and so even when the top of the soil dries out, they can still access water, but it cannot support annual crops. Understanding this is critical. This is precision farming for small farmers. Secondly, we need to then seamlessly share knowledge globally. These are two soils, one in Namibia and one in New Mexico in the southwestern United States, that have virtually identical properties, and in fact, as we were talking earlier, they smell the same, which means they have a lot of the same biota. We, together with a number of partners globally, are developing something called the Land Potential Knowledge System, which is an open source suite of mobile apps connected to cloud computing. It's an open system for storing and accessing user data, so people have the ability to collect data and share it with each other. And most importantly, it's a system for selecting relevant data. How many people here have or grew up on a farm or have a garden? Wow, that is impressive. Somebody take a picture of that. That's phenomenal. Everybody raise your hands again. The photographer can get people who have either raised on a farm, have a farm, or have a garden. That is the highest rate I've ever seen in an audience. That's cool. So you know what I'm talking about. I mean, I'll go home now. So the challenge then is when we're looking for information that can help us to be better stewards of the land, where do we go? We can go to our neighbor. Great. We can go to Google. Not so great. Google, we get everything from everywhere. We have no idea if the information on Google is relevant to our piece of land or not. My wife and I bought a sustainable house in southern New Mexico. It's a passive solar adobe, wonderful from all sorts of perspectives. It happened to be on a hectare of irrigated land for pecans. I'm a rangeland scientist and an applied soil physicist. I know nothing about raising pecans. I got on the internet. Boy, was that a waste of time. All right? I want to know how to manage my land right here, right now, with my questions today. Okay? And we now have the technology to bring the knowledge and information that is relevant to bear on that. And this, and again, I apologize for the complicated slide. This is available on our website, landpotential.org. But basically, the idea is, with the mobile phones, we can generate information or solicit information from the user that helps us identify what the soil is. Once we've identified what the soil is, we can then run potential productivity and degradation models so that if you're going on to new land, we at least have some sense of what the sustainable production options might be. If we're trying to improve production or restore land, we can do the same, and then ultimately link to those management options that are relevant to that specific piece of land. So again, think about Amazon.com or any other shopping website. It does a pretty good job of figuring out what you might want to buy, even if you hadn't thought about it before. Right? We want to do the same thing for land. Specific piece of land matched to the knowledge that's needed. So, and the idea of this system is not only to support farmers and pastoralists initially through extension using these tools, but also support policymakers in targeting crop insurance destocking, quick checks if somebody is coming in and is proposing a large land purchase and is proposing to convert that land, say from rangeland to cropland. Is that even sustainable? We'd like to give people the ability to walk out into the field with a mobile phone and complete that check, or at least not with complete confidence, but at least some level of confidence of what is possible. How does it work? We are developing and already have a couple of apps out on the Android Play Store. They'll be available soon on iPhone. Land Info is used to characterize the soil profile using icons and provides immediate outputs on things like climate, plant available water holding capacity, etc. And so this actually is a one-click button as you're driving around the countryside and wondering what the climate is in that area, trying to figure out if there are no plants there because there's no rain, or if there are no plants there for other reasons. This provides that information globally. A sample output, again, plant available soil water holding capacity. In the future, it will also provide more information on what the potential of that land is. The Land Cover app is used for monitoring vegetative cover. And again, this is all on the website. I won't waste time here. But basically, you can go in and in real time see as people are uploading knowledge and information. So to conclude then, looking at open source, open data, citizen science linked to specific soils and climate that allows us not only to share, but also to test new SLM technologies. And here I'd like to refer to some work that Edmundo Barrios is doing here at ECRAF, basically using something called impacts to help people better understand their land and the relationship between the soils, the soil biodiversity, the productivity, and also test using paired control approach new technologies that are being developed. So in conclusion, I am really incredibly excited about this. I'm thrilled to be the talk right before the actual presentation of the book, and with that I'll turn it over. Thanks.